Hello, this is Module 7, Lesson 3, which is groundwater. So the focus question today, how does water flow through rock? So it flows and infiltrates into the ground. So how does it do that? All right, so the water cycle is important in this because the water cycle is what allows the water to move into the ground. So the water cycle involves evaporation, condensation, precipitation. It's transpiration from the plants, which is really important and vital. And then you've got infiltration into the ground. So, as the water comes down, evaporation from seawater or lakes occurs, and that goes into the atmosphere and precipitates down into the ground, into the lakes, the rivers, and then that infiltrates down into the ground. So, this infiltration, this word is important, infiltration into the ground. And that's how precipitation gets into the groundwater. So it depends on the type of rock, and it depends on the pores, which is the spaces in between the rock. So it depends on a lot of things. The soil that we have around here has a lot of clay. And so clay doesn't allow the water to move through very well. Whereas areas that have a lot of topsoil, the water moves through very easily. So if we look at the way groundwater is stored, it's stored in the pores between rocks. And so you've got rocks, dirt, whatever is in the ground. There's little tiny spaces between each of the molecules or atoms or stuff like the dirt, rocks, that kind of stuff. So the little spaces are called pores. And so that's where water is stored in the ground. It's not just like a pool, a vast pool or a lake, but it's stored within the little spaces in between the rock that are called pores. So the more pore space the rock has, the better storage it has. So here's an example of 3 types of pores. So the one on the left, this one, the pore spaces are large. This one, the pore spaces are kind of mixed. So it's got a lot of spaces, it's got small spaces. It's not very good as far as water storage goes. And that's because water doesn't move through mixed material very easily. And then this has small pore spaces, but the pore spaces are connected. So the water is able to move through decently. So we've got these different areas in the ground. One is called the zone of saturation. So this is where the groundwater can seep down in through. So saturation means saturated, means it's full of water. So this would be right here. This is our zone of saturation. And then we've got these other things as well to remember. So here's that zone where things are fully saturated, so it's full of water. And then we have the water table. That's where the water, the line basically, that divides the area that's full of water, like this, versus the area that is not full of water. So the pore spaces are empty here or only partially full. So that's called the zone of aeration. So zone of saturation, zone of aeration, and then, of course, we've got the ground on the top. There's also a couple other things that we'll talk about in here. We've got the water table. So the water table is essentially the top of the zone of saturation. So you can see right here, the water table extends up. It kind of mimics the topography. So it's always not always a flat line that goes clear across, but it tends to mimic the topography. And then if there's times of drought, that water table drops because water is leaving this zone of saturation. Maybe it's getting pulled up from wells. Maybe it's being used by plants. But that water table will normally fluctuate depending on if we have high levels of rain or not high levels of rain. All right, so if we look at this, here's the water table, and the water is flowing down here like this. And in order to get to this water table, this zone of saturation, the water has to infiltrate down. So it's not going to infiltrate down through cement very well. So if we cement areas, it doesn't get in very good. That way, that's why it's essential really to have parks and natural areas, have lots of drainage through the cement, areas where the water can actually drain through so that it can get to the bottom. And it also takes everything that's with it. So when the water infiltrates down through, if there's any pollutants on the surface, that goes with it. So we always have to be really careful of what we have on the surface, like oil or that kind of thing. So the water basically seeps down until it fills up the pores, and that would be the water table. So if it's going to rain a lot, then the water table will rise as long as it can, as long as the ground will let it. And then as drought occurs, then that water table goes down. All right, so it moves through this area between the zone of aeration and the zone of saturation by this thing called capillary action. So capillary action is how water likes to stick to other water molecules. So if you've ever used a paper towel and you kind of place the paper towel a little bit on the water, and then the water seeps up through the paper towel without you actually physically touching the whole paper towel, that's capillary action. So water will move up and down in this capillary fringe. So it's not like a definite line at the water table. This will be an area where it's mainly half full of water, maybe half air. So it's kind of this area, this gray area here. All right, so here we've got a couple new terms. So this is impermeable, meaning that nothing can move through it. So like a window would be impermeable, whereas a screen would be permeable. A screen allows air or water to go through. So this impermeable rock, water cannot move through it. So it's not able, it's like clay. So the water's not able to move through. So here's our zone of saturation. Here is our zone of aeration. We've got water movement down. We've got a well built here. So think about what would happen if the water table dropped below this well. Well, the well would go dry. So we don't want that to happen. So we either have to build our well deep enough, or we have to be very aware of where the water table is and be very careful at preserving and conserving water. So here's some impermeable rock. So this orange is impermeable. And then you can see it's raining up in the mountains and the water is seeping down through this, what we call an aquifer. And so an aquifer is just an area in the ground that is the zone of saturation. And so notice how water can't infiltrate down through. So we might have another small water table on top of this. And so this is a deep water table or aquifer. And so in order to get to this, the water can't just seep up on its own because this is an impermeable area. It's called an aquiclude. So that means impermeable. So the water cannot move through it. So this water coming down, this is force that's pushing it down because it's moving by gravity. So what's going to happen is it's going to be under pressure, and that's going to create either geysers. It's going to create artesian wells, which are wells that the water kind of just bubbles up on its own. Sometimes it could cause springs, so areas where water just kind of seeps out. So here's what happens. The recharge is how it fills back up. So we take water out, maybe through this artesian well, and then the water filtrates through this aquifer and is recharged up in the mountains. It's not recharged anywhere along here, and that's because this is an impermeable layer, so that the water can't move through it. So it has to be recharged in the mountains or further away, and then it comes down, and because it's going downhill, it's under pressure. So if we tap into this, all of a sudden we get water coming out, kind of like similar to oil. If you've ever seen somebody strike oil like in a movie and the oil just sprays out everywhere, that is the same example. It's under pressure, and when you tap into that, it comes out. All right, so I mentioned springs. So springs can occur when there's a hole in the water table. And there could be a perched water table. So here we can see, here's the aquifer. This is the zone of saturation. Here's the water table. And then up here we have this perched water table. So this is a aquiclude, or an area that's impermeable. And so we have this water kind of sitting on top of it. And so it's exposed right here, and the water seeps out. So it can rain through here and seep into this. It's stored here because it can't move through this aquiclude. And then you can see it here coming out. So that's why we get springs sometimes in areas, especially around here where we have a lot of mountains, we'll get springs. And those are just from those perched water tables. And this is pretty cool. This is a picture in Yellowstone. Yellowstone is pretty amazing. It's our first national park ever. But there's lots of hot springs. And so here we've got water that's being discharged from the ground. Sometimes it's under pressure. sometimes it's a geyser and it's under pressure, and that's because of heat. So it gets hot. Sometimes it's just sitting there warm, and that would be a hot spring. So the difference between a hot spring and a geyser, hot springs are just naturally warm springs, whereas geysers heat up and that steam under pressure causes it to erupt. So here's a geyser. Here's how a geyser works. So we've got this water down here is being heated by underneath. We've got magma or something underneath there, and it's heating up the water. Well, the water seeps up through these cracks in the rock, and basically it becomes pressurized. So kind of like a kettle, like on the stove. So you're heating the kettle up, and when the water gets warm enough, the steam pushes out and causes it to whistle. And so that would be the same kind of concept, except for the steam is coming out of the geyser instead, out of the ground. And so Old Faithful is a really good example of this. And this is a video showing Old Faithful. It's pretty amazing. It's they call it Old Faithful because it erupts, I think, every 90 minutes, something around that. It's very close to 90 minutes, I believe. Whoops.
Wow!
So you can see how big it is. It's pretty big and it's pretty cool. I've seen it before in person. It's pretty amazing. And it's superheated water, so that's water that is above and then it kind of just goes back down into the ground and has to heat up. So basically all the steam was let off, and so now it has to heat back up before it goes down. So wells are how we tap into the groundwater. So wells are just whole things that we dig into the ground to tap into groundwater. So a well can be tapping into just normal, and we have to pump it out, or it could be an artesian well where because it's under pressure, it sprays out. And so when we dig wells, we want to dig them below the water table. So you can see, and this can result from heavy pumping. So this is called drawdown. So notice how wherever the well is, it kind of dips, the water table dips down, and that's because you're pulling water from the water table, and so it causes it in that area to be depressed. So right here, we've got a well. This well is really in danger of going dry. This well is tapped in really deep. This well is not at all either. So look what happens after time. So this well is drawing water out. It creates this cone of depression. So the water table is lower. These wells are now both dry. So that's a serious problem for a lot of people, especially if you're living with well water, is that you want to know how deep that well is, because where the water table is very important in times of drought. Your well can go dry. So so this is called drawdown when that happens, when it becomes drawn down because you're pulling water out. All right, so they create that cone of depression. Water rains again. I mean, it rains again and fills up the aquifer, hopefully. So that's in normal times, but we know in California that we have times where there's lots of drought. So we just have to be really careful of that. So here's what I was talking about with the artesian wells. So artesian wells are between two layers that are impermeable. So here's an impermeable layer here, an impermeable layer here. And then we have these artesian wells, which basically the water will come out under pressure as long as there's enough pressure. So here, there's not enough pressure because it's a little bit higher up. This one, there's enough pressure to cause it to come out on its own. So that would be an artesian well. So it's under pressure, the water will naturally come up by itself. So this is what I was talking about with being very careful with our water. So this is showing the San Joaquin Valley, and that's in kind of this like Bakersfield, Modesto area. So this is the ground in 1988. This is the ground level in 1988. This is called a subsidence. So when the ground sinks, 2004, 2008, 2016, pretty significant. The ground has dropped 6.5, 7 feet in what is that, 40 years. So that's pretty significant. And what happens is the layers, so as you draw water out of the ground, those pores become compressed by the weight. And so if they become compressed, it's not just going to rain and those layers are just going to magically like pop back up. They're gone. So this is quite a bit of area. If we look at this 7 feet and times that by the entire area of the Sacramento Valley, that is a huge amount of water that's gone, and it's gone forever. We can't get it back. Even if it rains a ton, it's not going to come back. So it's really, really important to not take too much out of the ground and be very careful with water. So different ways that we can protect our waterways is by not polluting. So anything that we put in the ground, even if I dump something in my yard, it's going to eventually infiltrate down into the ground and move into the river or the water supply of Redding or my well. So it's really important that anything that touches the ground is going to eventually end up in the water. So it's really important to protect that and prevent pollution and things like that. All right. So things that we have done, we build things called impermeable ground barriers, and that prevents like a sewage area, for example. We build areas that doesn't leak into the ground, so we don't want that into the ground. Chemical treatment plants, we want to layer with something that helps protect that. But it's important that humans know what we're doing. So anything, like even if you throw a battery away that goes into the landfill and you didn't recycle it, that goes eventually leaks out. And if we don't have good barriers in the landfill, then that's eventually going to leak out as it erodes and corrodes into the groundwater. So we have to be very, very careful. All right, so this little video you'll like.
Hey, what happened to my water?
There's something here that you should know. The story of water from down below.
Oh, I'm groundwater, I'm all around. Most of your water is underground. The water we have is all the same. I'm used over and over again. I surrounded the castle with a watery boat, and I float along on a hookfin's boat. I once dripped down as dinosaur drool, and now I'm the cool that fills your swimming pool.
Feel the drops of snow and rain, an age-old cycle again and again. Groundwater under the ground, groundwater flowing down in the ground. Groundwater all around, groundwater. Don't you know why we care? The water we use is everywhere.
Riding along the aquifers, deep down under where no one stirs. I feed the lakes, streams and land. I'm pulled by wells, I'm in demand. Float along the great help keep it clean.
Swim, shake and spray. We all use water every day. Some for fishes, some for dishes. But is there enough for everyone's wishes? Use it. Groundwater, don't abuse it. Groundwater, we use our groundwater every day. Let's make sure it's here to stay.
Oh, rainy days, I must lament the troubles I have with tar and cement. I can't feel the ground if I can't get through. I'm groundwater, my power is vast, but waste and pollution keep me from my task. If we're not careful, clean water won't last.
Not some help, we can't carry on. What will we do if the water is gone? Every time you brush your teeth, remember the water underneath. Next time, wait, stop and think before you don't stop dancing. Do your part for water power. Learn to take a shorter shower. Stuff that makes the grass look swell will end up later in your well. Protect groundwater, conserve groundwater as we plan to build and grow. Leave open space for water to flow. Be aware, groundwater, show you care. Groundwater, now you are in the know. Don't forget the water down below. Don't forget the water down below. Don't forget the water down below.
Oh, I'm ground.
All right. So hopefully you have that song stuck in your head all day. Just kidding. But it's definitely a good message. So hopefully you enjoyed, and I will see you next time.